Hello, welcome back to the stream. I'm Jun Chan, and we're back doing some Purescript and some graphs and implementing a Comonad on the algebraic graph library that's been ported to Purescript and that we've been adding some tests to, and some libraries, some not libraries, but some data types too, since only the directed graph was implemented, and we started implementing the undirected graph. And where we left last time was that we had, yes, a Boolean here. Yeah, we were trying to test the Comonad instance that we have started to work on, that is on focused graphs right there. So this should, a focused graph is just a focused key, so a focused node and the graph without that node. I didn't think of that. This is not the graph without the node. So it could be that that's the reason why actually we need a pointed graph with a context, because removing the node without keeping track of the edges doesn't make sense. Okay, so that's a good start. We just need to delete, I think, our focus graph instance. Is that true? I mean, I think that's true, right? What did I do with the duplicate there, the graphs? I took my graph, and then for each focus, I created a focus graph that focused on that, but it didn't remove the No, you know what? I'm not sure that what I'm saying is correct. We can maintain the whole graph here. There's not, I mean, we up to us to maybe make a graph here that has the context removed, if that's how we want to play it, which is probably, I think, the intent of what we've been trying to replicate here. But, and I suppose that's because we want the graph to be inductive. But I'm not sure whether we need that. I am not sure whether we need that. Meaning, I think it's probably fine to have a complete graph with the node that's focused. And then to do exactly what we did. No, I think it's probably fine, actually. So what does a duplicated graph with a focus graph inside, what that should look like? Okay, let's try and unpack that. So it's going to be a focus graph, but there's going to be a graph here, and then there's going to be a right, because the key is going to be a whole graph, or a focus graph, right? Yes, the key is a focus graph, so it's actually this very focus graph. So let's name it so. And then we have graphs here, and graphs is going to be what? yeah, it's not a tuple, it's focused. It's focused graph. And here graphs is going to be a graph of focus graphs for which the first so do we want to do an adjacency list of that guy, or do we want to build that? Let's try and build it. So it should be a graph. Where there is an edge between the two graphs. So maybe, and they're going to be focused graphs, right? So focus graph true and focus graph false, I think. Such that focus graph true is actually graph, and focused graph false is actually focus graph false edge true false. And not sure why we need a show instance here. I think, oh, I see. Should equal depends on show. Oh yeah. EQ and show. Huh. Okay, well, I suppose we can do a show instance. What is the show instance for graph? Maybe an internal. Yes, we never actually should equal graphs directly. We use the adjacency list, which does have the show instance. So if that's the case, then well, actually we don't know how to get an adjacency list from focus graphs either. Yes, so which direction are we going to go? I suppose we could just pattern match. And yeah, maybe we can do that. Let's see what that would look like. So if we say duplicate focus graph, and that we say let focus graph G and GG, then we could say something like G should equal graph and GG should equal graphs. Except that G is again a focus graph. So we'd say kg, and we'd say that k is true. And G equals graph, which is edge true graph. So now maybe we do use our adjacency list, and we just this time we say we use the edge, which is I suppose that's that one. And now we need to do GG, and that's a bit more tricky. Because GG is a graph. But if it's a graph, we can do an adjacency list of it. And I think what we should find in that case is that it's actually a tuple of G or focus graph true, or maybe true, and no, it's focus graph true to focus graph false, and focus graph false to focus graph true, I believe. And I think we don't need that, except we just do like so. And right, so obviously we're now stuck because we can't do, because our focus graph true is doesn't have a show instance. Do we want to show instance so that we can actually do comparisons? I think it's going to be a little bit tricky. I mean, it could use the adjacency list, but then we'd have to do one for focus graph. So what to do? Not very satisfying. Okay, well, let's check this side of the code first. And introduced but not used, that's just a warning. Okay, so that does pass the test. So maybe we let it like this. We let it rest for a bit. And what did we write in our log for the next thing to do? And why don't we duplicate this for today, October 2nd. Okay. So yeah, we're finishing this Comonad for focus graphs. So if we could have something equivalent to a adjacency list, which would return a tuple of the focused thing and the graph, the adjacency list of the graph. And maybe we wouldn't want to call it adjacency list. Oh, let me start the chat notifications here. Looks good. Yeah, I'm not quite sure what to do here. Yeah, one thing I could do, since I could introduce maybe a focused Comonad or something that would allow us to move into the graph. Maybe with a focus, we already have focus. Is that what we want? Focus works on a graph and returns a focus. And do we have a refocus? We also have a refocus, but that's for the pointed graphs, something we were maybe going to build later for pointed graphs. So you know what? Let's postpone writing it for pointed graphs, and let's try and write it for focus graphs. So where would it be? You would take a node A and you would just put the A right there. Which is not very interesting. in fact, we would need to return a maybe focus graph. So if we have a context with the node and its arrows or edges, we sort of have a guarantee that if we move along one of the edges, then it will exist. So but that's already our pointed graph, which I think I want to call like context graph or something. I'm not sure about pointed here anymore. So in that case, I don't know whether we can make use of that. Sounds like we would need dependent types or something. Or maybe something lengthy. I don't know, because we want to say that if we have a context and that in that context we pick an edge, so this could be some kind of like a lens on edges. Of a that this would have to be a valid lens into context prime A. Let's get context prime closer to us. Maybe together with this context prime here. Yeah, the problem is that no, we can't really guarantee that, because the list, we don't know the size of the list. If we carried that in the type, then maybe we could make a type safe refocus where we could return a context graph instead of a maybe context graph. Okay, well, let's for now play with a maybe focus graph. And here, context returns a maybe context, but we don't use the context in the focus graph. So we only need to know whether the A is inside the G or not. So we can get the FOK from focus again. just, and the predicate is A equals. Okay, so now we have another way to test, I think, our focus graph. So we can, well, we can extract, and that should equal true. I suppose we could give a name to our focus graph, F, or FG. So if we extract FG, that should be, oh no, that shouldn't be equal to true. Well, if we extract, then that should be equal to true. Okay, maybe parents. Yes. Except we broke our graphs here because we changed still pointed graph here. Okay. And yeah, lens edges, that's, we don't know that. And we need EQ for A, yes. Right, and so we need a refocus that's like this. Then we define refocus twice, which really again makes me want to implement the classy version so that these would all be instances. The other option is to create put those inside their own data type, right? Okay, did we start a class? We did. Any graph. Fine. Refocus prime. Refocus prime. And yeah, I think we have an A here. Yes. And we want to export refocus, I believe. And now what? Now does this pass? It does? Okay. So let's try and let's try and refocus the external FG. onto the internal FG. Maybe we call it AI. I don't know, but that's already the case, right? That is already the case. So it's focus graph. Yeah, let's just build it, because that's actually, I think, this guy. Okay, so actually let's rehabilitate the where and say that we refocus on focused graph false. Then we extract, and I suppose we suppose that, well, actually we need to case on that, and if it's a just f, then extract f should equal false. And if it's nothing, then I think it should kind of error. Should return NTTU. Okay, let's make it fail manually like this for now. Don't know a better way right now. And we have problems with parsing. Yeah, because FGI is a problem, and we have not imported focus. And yeah, I suppose we can actually get rid of this. And where maybe should be a let. And this should be probably parents. No, because we should extract twice already. Okay. And why do we need EQ now? We need EQ because refocus needs EQ. And if we can't make focus graph equivalent, then we have a problem. But we should be able to have EQ. That's really easy. In fact, maybe we can even derive it, can't we? Well, we would need to say that we can derive it if we have EQA. Isn't that how it works? We need the ORD. You need EQ and ORD. Yeah. This syntax. Okay. But then here seems to compile, and yeah. And it passes. It's a bit convoluted. Certainly not very pretty. And this is more about refocusing, to be honest. So I do use the Comonad. Doesn't refocus on a missing focus. So let's say focus graph missing, maybe something like edge false false or something, and then we can try to focus on that, and that should be true, but that shouldn't. Yeah, passes. So maybe that's enough with our focus graph, and we can start with our pointed graph, or what we call our context graph. Okay. Here. Undirected focus graphs. Do I want to do that? Maybe not. Maybe I want to do pointed graphs or context graphs first. So let's try context graphs. So we have a context. prime, call it, and a graph. And refocusing is probably going to be the same thing. But indeed, I think, do we want it to be on an, I mean, I suppose one can be on an A. Yeah, I think that's okay. And then what's it going to look like? Something similar to this, where we have a context graph here and a G. Then we'll go through our graph and but to know which edges to, well, we have them in the F, so that's great. So we can do vertex is A, and then inputs is f.is, I think, and outputs is f.os. And we just need EQA. And we need to return right. Here we'll need to assume that this is always correct because we map onto the A. So our GG is full of things that are refocused. But full of maybe refocused things. And so we need to assume that it's always going to succeed here. And so we're going to do what for that? Let's see what we have in the maybe package. I think we could use maybe. Or from maybe as a default value. Where would be the default value? We kind of want to throw, so it's a little bit tempting to do unsafe partial blah blah. Purescript unsafe partial from just. Yeah. So let's do that. Unsafe partial from just. And then import that. Import that. And ask for EQA. Okay. Yeah. Interesting. I don't think we can have a Comonad only if we have EQA. I don't think that that works, does it? Okay, so maybe there's a subtlety here. Let's see what we had in the FGL library. Yeah, no, like our Comonad instance actually needed some constraints. So yeah, okay, so EQA extend context graph A. Is that right? GRK edge. Oh, that sort of explains why you would want to have a K there instead of the A. Maybe the fact that we have only one type constrains us here. Because we could have a context graph of A indexed by K's that have an index inequality on them. That would be fine. Interesting. I shall go grab myself something to drink. Be right back. Okay, so how? Oh, I don't need that view. How do we deal with our constraint? Here, I think it is like this graph is parameterized by a K. Yeah. Vertex, nodes, and edges, and I think N is some kind of a node IDs of type V actually. Okay. And node labels N and node label E. So but argas are not like that, right? They're just on A. If we have EQA, we have EQ context A. That's not so so important for me. Just maybe EQ on. There's no EQ on graphs. What? There isn't. Oh no, there is. There's an EQ on graph if there is an ORD on A. Interesting. I imagine that that's for efficiency. It's because it uses two adjacency map, which requires ORD A, which you could say is for efficiency. But that doesn't tell us anything about more sophisticated instances there. I mean, like we see that monad doesn't have any additional constraint or anything. Is that something really that's not possible? It's something I hadn't realized. It basically says that extend takes something of kind type to type and returns a constraint. I mean, that doesn't make sense, right? Because there's no A's anywhere. And non-type variables, exactly. Hold on, I think I need an aparté there for this, meaning I need to check something more simple, like well, let's say yeah, let's say a list that's nil, or can't say list A. If I say, if I do my class where, I don't know, size equals, or how about just nil? Nil is F to bool, F to boolean, is that a thing? Okay, and now if I say instance my class list, so we want this to be type to type, and so do we want that? That doesn't make sense for A? No. Let's say head. Then we want it to return an A for all A, which means we need a non-empty list, really, right? Which is fine. We can actually make it so, and then implement it such that const A blah equals blah. Okay, yeah. Let's call it HD. And now we're back to only warnings. And so if I wanted to say something now where I need equality on A, so let's say well here, well, yeah, it's supposed to work for all A's, so I can't really say EQ2 because that would only work for a specific A. And I mean, maybe that could work. Well, right, true, and then Q2 and anything else will be false. Does that work? It does. Okay. Right, okay, so now if I want to say EQA of FA, then I suppose I could put the constraint here, and then I could say EQA, and there would actually be only a single, I mean, it's really, the head is equal, right? Let's make it a tiny bit more realism here, and then we'd say equals A. Yeah, an A and an FA, so an A and a B, and we'd have A equals B. And anything else would be false. Okay, so now, yeah, well, we just need for all A, set that EQA. And apparently that's unreachable. Yeah, it's unreachable, that's true. So that works, and we can put our EQ in here. But here we don't have control over that, right? I mean, it's just an impossibility. I can't talk about A here, so I can put EQA here, but I can't obviously change the type of extend because that's not the right extend, right? That's I can't just decide that extend all of a sudden is going to be A to B, WA. I still don't know this by heart actually. That's WB for A. Yeah, it's supposed to be for lane B, so if I also then say but no, QA, then I'm kinda not okay, right? No type class instance was found for EQA. Which is the same error as this. Not exactly. We probably need EQB as well. So is that really a Comonad then if we need EQ? Yeah, no, it's fine. It's just because of this carrier type thing. Okay, so we could, I suppose, have some kind of phantom type here. Would that even make sense? What if we said that we had EQ key already somehow? Would that work? I think that's possible in Haskell. Purescript data type with constraint. Data blah blah. So that sounds possible. So it means when we pass, do we also need to do that. And what does this even mean? Then we can't derive the instance, but I suppose maybe that's okay. I don't know that this is what I mean. It's interesting that I can write that though. But I think that what this means is that the context graph is something that maybe is a context with equality. I mean, that is kind of what we want to say, isn't it? And if we made a new type out of that, would that solve something for us? Yeah, I don't even know what to search. How come we didn't need that here? A refocus needed an EQA, and we used, but we didn't use refocus in extend. We just picked the FG. And put it there without checking it. Ah. So I suppose if we could we avoid having to refocus? If we pass a context here, then yes. That's not true. My duplicate here simply takes just slots the FG right here, and that doesn't work because we want, well, that we want a context of FGs, so that's fine. That's fine, but I think we don't know yet what to put here. I mean, yeah, but then GGs are, let's remove this. A graph of context graphs. here I just rebuilt a focus graph. Centered on A using the functor instance. Why can't I do that? FGG. FGG. FGG was map. A focus FGG. Yeah, I suppose it's just that A. Oh, the map instance. And maybe it's just that I need to implement. Because what's going to be the type of map coming out of that? Going to be going from a function from A to B, an FA to an FB, right? So context graph A to context graph B. And so that's fine, but I need to create a context here that makes more sense. Okay, so let's try and do the same trick as we did before underneath, just for now. See if we type check and then we think. And we now can remove EQ. And we type check. So this might be nonsense, but it type checks. I mean, it is clearly nonsense. I mean, we have utility functions to get from a vertex. We can actually, well, it's that focus thing, not refocus but focus. And we don't need the EQ for that, so why am I not using that? So let's get the type of focus right here. And so we have a G that's a graph. So if we map with an A, and then we case on focus yeah, well, that, yeah, we would have an EQ potentially here. Interesting. Yeah, we can't magically select an A without being able to pick one, to recognize one when we see one. We could pass a function from A to bool here, from key to bool. If we explicitly passed some form of predicate, then I suppose we would need the EQ type class. That would work. It's very strange, but it would work. I must be missing something important here. There must be clearly other comonads where we have to pass EQ somehow. Class of function. For instance, on streams, right? Why is that JavaScript? Oh, because it's the presentation. Behavior comonad, front-end comonad, back-end monad. Yeah, actually, WAGs maybe is an example, a good example. Haven't looked at WAGs code yet. Row type. Okay, wait 1 second. I could also do could I do this? No, I can't, right? If I had a phantom type, that would make sense, right? So, okay, Comonad instance of non-empty list. That should be one that would have an EQ instance, wouldn't it? Non-empty list. Comonad, non-empty list. Okay, show me. Oh, is it because I'm trying to do duplicate instead of extend? That could be. That could be. Because if I do extend, I need to do it on all values. So I don't need to check which value. Kind of makes sense. Although you could say the same thing of duplicate, couldn't you? So maybe it's just that reusing this tooling, the focus tooling, is not the right way to go about, because it requires this constraint and because it does the fold for us. And it seems like maybe we just need to do the fold ourselves. Or maybe just using an instance of foldable, which I think is what's happening here. But they're not foldable. Despite the fact that we have a fold G. Is alga foldable? It is not. And maybe adjacency map or adjacency list is. It is not. Well, obviously adjacency lists are. Oh, I say that, but well, yeah, in this case they're just lists. In our case here, yeah, they are foldable. And these lists. And the foci goes over these lists. So duplicating, have my focus, have the rest of my graph, put the whole graph in here, that's fine. And then I go through my whole graph, removing the vertex that I was focusing on ideally, but let's say I'm not for now. Then I go through my whole graph, so I need some way to fold over it, and I could do from adjacency list to adjacency list. That's possible. Or I could use fold G, which is, I think, pretty much equivalent. but we're really traversing rather than folding. And I suppose it's okay if we say that the accumulator is a graph, and then each time we find a node, we construct the graph with the context on that node. And then we still have the composition decomposition problem. Meaning the edges that connect the graph, the edge to the rest of the graph. Because that's the problem right now, right? Here it's trivial to get the vertex. We say we map over all the cells of the graph, and we create a graph which has that create a context graph that has that cell as the context. And that's easy dandy, but shall we just apply edge list? Here vertex focus takes this 8 ball. But if we call it, if we say A to focus A instead, and then we fold G with that, let's try that. Let's see what happens if we so I'm saying I'm not mapping on G. Instead, I'm using a function focus prime, which instead of taking this guy, I'll take a V. Maybe I want a graph of foci. It kind of makes sense, actually. But then I need to be able to take my graph of graphs and annotate it with the corresponding graph of foci. And that sounds difficult. Although I suppose if my V here is something like, I wonder whether I couldn't get a context graph of context graph A here. That sounds plausible. And to do that, I think V would need to be something like A to context graph A. And that means I would take the A and no. You would return a focus of context graph A, something like that, no? We connect our foci. List of A's and this OK. That's being true. Or simply we use 4G again and we forget a bit about our, I mean, we use something similar maybe to aggregate, but we forget about specifically foci, even though they're going to look quite a bit like those. So maybe we say empty CG, connect CG, overlay CG, and vertex CG, or something like that. And then we say empty CG, we don't care about the OK, I think. We care about, so we make it a context prime, basically. So, is that right? Yeah, I think so. So for LA context prime of A, something like that. And so is really equal to I suppose that's why you have an MK thingy. So let's make one. MK context is VOs equals inputs. Okay. Vertex outputs. And empty, a well, right. What do we put in the middle? Indeed. Indeed, indeed. How does this work in here? Because you make it a list. Yeah, I don't think that works for us. Let's look at the type of full G. Takes a B, which we want to be context graph A. So we start with we need to start with the context graph A, and that's the empty guy, which arguably is a CCG, but we don't know what to put here. Huh. Maybe there's a maybe there's a non-empty fold. Because we don't have, if we have a non-empty graph, then we don't need to take care of the empty case. And therefore we don't need the E. That is probably what's going on. So let's try a focus a full G prime, which doesn't have the E. Therefore doesn't have this, and therefore works mostly on non-empty graphs. But have we properly specified what a non-empty graph is? We haven't really, right? It feels a bit like we might. Yeah, okay, you know what? That's actually a good candidate for a different module, because if all of our stuff is going to depend on that, then we'll want to scope it and so on. Okay, and then we just take the bunch. Okay, yeah, I suppose it should go there. And we say this, and we export it as graph. We export probably all the things, and then we just fix the types. or simplify them rather. We just take everything and we just remove all our shenanigans until context, I think. And yeah. And then we follow the types. And there's no empty. Oh, I should probably just type check on empty here. Yeah, our fold G is going to be dedicated. We're not gonna have plus. Well, so be it. Maybe that's going to break our class hierarchy, but I'll deal with it. Non-empty array from maybe empty. So okay, we'll see later. This, I think, yeah, maybe this should maybe click into place, I think. Empty, we remove empty. There's no empty check. Ignore this. And then our fold G will not have the empty case. We're probably gonna have to do something with this empty here. Not sure why yet, what rather. And fold G will not have the empty. And we can't have empty here, so that's going to be a problem. I'll deal with it when we get to it. And same thing, no empty here. And yeah, no empty focus. Blah, and subgraph empty, that should still be possible. And therefore we don't need to use this 4G prime, we can use 4G now. And we just won't have empty CG, so now we can focus on the thing we wanted to focus on. And what's up with that now? Empty. Yes, indeed, we don't have this anymore. Nor is empty. And then there's a bunch of empties here. Okay. So overlay a given list of graphs. So I suppose maybe we need the non-empty list. Non-empty list in that endo format. Don't know exactly what that's going to look like. Yeah, let's search for non-empty difference list. Let's say in Haskell. It exists. How about in Purescript? Those aren't difference lists, so maybe not. Oh, look at that. So dlist, instead of being endo, goes from array to, well, I suppose non-empty array then. So we need a new internal for that, it looks like. Interesting. So in that case, I suppose maybe we should put it at the root and then create a new anygraph folder with the relevant internals. Yeah, it won't be endo here. And we'll need to have a non-empty array. That's array non-empty. Non-empty. And what will we have for that? Yeah, we just need to say non-empty array A, I believe. And then our anygraph will import from anygraph internal. And then we'll have a bunch of things that won't work anymore. Okay, but that's where I'll stop for today, because that's already a huge new avenue. So what we're doing, we basically refactor to make focused and pointed slash context graphs based on any graph, and any graph is based on any graph.list non-empty difference list. And then I'll go take a look at the Arga Haskell repo and do a little search on non-empty here. See if we come non-empty graph. That is a thing. It's a whole thing. It's exactly what we've been doing. Excellent. So that's perfect. So we don't have to do that. We have to port all of the non-empty stuff. Port blah, not that. Glad I checked. And so yeah, so let's see, algebra.graph and non-empty. Let's see, what do they do with the list? They import data list.non-empty. Interesting. So they don't use different lists here. Okay. This is SQL. So we'll let's see, what do we do just to, well, we want to reuse the same hierarchy. So non-empty going to be what this is called. This is also going to be called non-empty. And here apparently, let's just double check this, but yeah, instance of this list endo array A that is imported in here with, it doesn't use those non-empty difference lists. So maybe we can make a choice for that, because you know, choose whether to use directly non-empty arrays or do a non-empty internal with non-empty difference lists, like those ones. And probably starting with the regular non-empty is going to be easier, so we can just do that for a while. Let's look at what the documentation says, and I suppose that's where you would expect to see Comonads, but they're still not there. But it has all of the fold G and so on, so that's going to be super convenient. Also uses that non-empty prefix. That's from data.list. And I think we have the same bunch of stuff. Maybe not as elegant here for non-empty array. Maybe we'll have to use non-empty lists. I don't know yet. Yeah, so that's what we'll do next time. Thanks a lot for watching, and see you on Tuesday for some more Comonads and algebraic graphs. Thanks for watching. Bye-bye.